All right, everybody. Next video, it's Sunday. I'm in the shop, and we're going to go ahead and do the follow-up to the checking accuracy of hole location video I did a few ago. And I'll go ahead and put a link to that up here, or up here, I think is how it works. Anyways, check that video out, and you'll see where we're going with this one. And we're going to go ahead and see if we can accurately place a hole on the Bridgeport, or really what we're going to do is check the repeatability and accuracy of traditional edge finding methods, because we did determine in that last video that the spacing between holes, because of the DRO and everything else, the spacing between holes is correct. It's just my inability to accurately pick up an edge. So the spacing shifts by like 2.5, 3 thou. So we're going to go ahead and see if we can fix that. All right, as you saw in the video, traditional old edge finder. I mean, this is, if I read this, it'll be real hard for you to see this, but it is a Starrett. It's probably 25, 30 years old. It's a Starrett number 827A. 3/8 on the body and 200 thou on the tip. Real standard. I mean, this is stuff that every machine shop has got. There's a little bit of corrosion on the body, but it is very free, and those surfaces look like brand new. This is what I used to edge find, and did not work so well. This is one of the tools I have. Now this is another one. This is also a Starrett, Starrett number 827B. So this is a large body. It's got a point finder and the edge finder up here. A little bit bigger body, still the same 200 thou tip up here. What I went and bought was off of McMaster Car. This is a no-name Chinese cheapie, but it does have a patent number, surprisingly. And of course it does cause cancer in California. But this is they call this an audible edge finder. I thought it'd just be fun to try. And you can see what's going on with the audible edge finder right there. They just machine a flat in it, and it kind of clicks when it hits the edge. So I've got that. I also purchased a brand new Starrett 827A. So there you go. Brand spanking new. Standard, real standard 3/8 body and a 200 thou tip. This guy is brand new. Never had a brand new edge finder. So we got that. And I also picked up a wobbler set. I had a couple guys in the comments tell me that this was by far the most accurate way to do things. And I did a little research, and apparently you're supposed to turn these much slower, about 200 RPM. So comes with all the standard tips and the body as well. So we'll compare all of this to what for me on the CNC machine has absolutely worked the best. And that is a Heimer 3D taster. So this is a real quality piece. I'm going to go ahead and throw this in a chuck, and we'll run this as kind of our reference. The first thing we have to do is throw it in a chuck and set it up. All right, I got this tool holder right here. It's got the proper size. Kind of what I like to do is take the set screw out. It allows me to visualize that I've got the flat lined up properly. Insert this. And of course, the flat doesn't line up properly. So for this guy, what we're just going to do is spin this 180 off. It will be good enough for this little test. And then we go ahead and tighten that down. And now what we have to do is spin this in the Bridgeport, put her up in the quill and spin it, and use these four set screws to move this around so we get zero run out on the tip. I've got the 3D taster mounted up, drawbar pulled in nice and tight, and I've got a little fixture set up. And basically what we're going to do is rotate the 3D taster and check out the movement here. And then we have to get this thing to not move when we rotate this. Then we know that that is perfectly centered on the axis of the quill. All right, so let's see where we're at. Just give it a rough go. We are not centered. We're going to have to do some adjustment. All right, so the first thing we got to do is get this thing loosened up, and luckily they put these set screws at the right depth. So I'm going to just loosen all the set screws. And then observe, it didn't really move. So as I turn it, it's getting tight there, so I need to push it away a little bit. Okay, you'll see here when I spin this guy, and I am spinning it, look at the tip right up here. You can see it move. See that? Those quick 2 adjustments put that guy right on the money. I'll move the Y in just a little bit so you can see right there. So you can see that it's actually touching, and we get no movement whatsoever. That's what you're after. Now I'll just pull the camera back so you can see. All right, now we're going to stick a piece in the vise and go. I've got a piece here that I finished off, squared off all the edges very nicely. So this is ready to go. We'll just put some parallels in, mount this in the vise, tap it down so it's perfectly flat, and that will be our start. It's a really nice old snap-on hammer, but like all of them, the plastic completely busted off. I still keep it and use it. I'm going to go ahead and move the Y here to about the center of the part, and you know, roughly about right there. And then we'll go ahead and lock that down so that never moves. That'll eliminate that variable. And then if it matters, I'll go ahead and set that as 0 so we know that never moves. All right, so now we're going to go ahead and power up the 3D taster. You see it comes up with 100 thou. That's because that round tip is 200 thou in diameter. So as soon as that reads 0, we are on axis with the edge. So we can just move this guy over. You can see the numbers coming down. Boom, there we go. So what I'll go ahead and do is then set that as 0. That is our reference edge. All right, I've got the very first one I'm going to test is my old Starrett edge finder. Got it mounted in a 3/8 collet, R8 collet, and we're going to go ahead and spin that guy up to 900. Give it a tap, get it wobbling. Come down, not like yay. And then we're going to come in ever so slowly. And I'll go ahead and zoom in for you. Okay, I'll go ahead and move in now, nice and slow. The frame rate might be doing weird things for that, but just about there, moving very slow now, right there. So, all right, I've got the audible edge finder mounted now. Go ahead and spin at the same speed. We'll come in. You can hear that? And what does it say? Boom. All right, the next one we're going to try is the brand new Starrett. So we'll go ahead and put it in the same collet. Gonna line up the pin. All right. All right. Same speed, about 900. Go ahead and get that guy wobbling a little. Again, the frame rate might be doing weird things. We'll see. Just about there. Going real slow. Boom, right there. All right, now the next one we're going to do is the brand new Starrett wobbler. So we're going to use this tip right here. This one is a 1/4 of an inch, so our number is going to be 125 if it works out correctly. And to put this together, you remove that, slide this guy over. Sorry if this is not in focus. Bang, like that. And then just lightly snug that guy down. This should be very smooth, very free. All right, wobbler. Okay, I've got the wobbler mounted in the same exact collet as all the others. Lowered down into position. We're running on slow speed this time, same direction, and about 200 RPM is what I've read and researched. Okay, so we'll go ahead and feed this in, and what's going to happen is That guy's just going to kick off to the side as soon as it gets pushed beyond its axis. Right there. About 1 thou off. All right, we're going to go ahead and redo a hole here for a dowel. And let's see, we've got same 3/8 dowel. We are going to drill this hole 1 inch in from the edge in X. And I'm going to do center drill, small undersized drill. I'm going to use an end mill to bring the hole back straight again, and follow it up with a 1 thou under reamer, and then press this dowel in, take it to the table and measure. Okay, here we go. I'm going to have to move the table down, give us some Z clearance. Whoops. There we go. Slow that guy down a bit. Okay. Done with that guy. Now, this end mill will go ahead and straighten that hole up again. I'm going to slow that way down. All right. And now the reamer. And to run the reamer, I'm going to go ahead and put the reamer in a collet. And that's a 5/16 collet. Gonna hang the reamer out quite a ways so I don't induce anything with this collet being sloppy or off or who knows what. We're gonna run that in slow range. We're gonna put a little lubricant, get those chips out of there. And we're going in and getting out. A little too aggressive there. There. In and out. And back over to the Dake arbor press. And we're just going to go ahead and punch that guy in that hole. It's a good fit. All right, let's check the size of the pin first. And we'll go ahead and zero that. Should be about 3/8. All right. So it's 3/8 plus 2/10. So that's way more accurate than I'll be able to get with my Mitutoyo height gauge. So we'll go ahead and fire this guy up. Running down to the table. This table's been all wiped off, very clean. 598. It's repeatable, so we'll go ahead and 0 that. And again, we should be looking for right there. We should be looking for, I'll give you a better view. 1 plus half of 3/8. So 1875. 1.1875 is our target to know that we're perfect. And we're not. And that's exactly what I was seeing before. 1.5 to 2 thou off. Let's make sure there's no burr on this part anywhere. There could be. I'll stone the edge. Okay, I've got a stone here. This is a 400 grit stone, so this is not going to take any material off to speak of. Just lightly across this face to make sure that there's nothing proud. Okay. Now we'll go back. .1890. All right, 1.5 thou off. So what are we going to do? So if I go back to that original, I punched this dowel out right here to use in that new piece, but this is that original piece that we started the test with. That's the second hole I did and found that it was off. So this is kind of what started all this. So we can place this guy back up here. How much is he off? It's about the same. So I'm repeatable, at least on that Bridgeport. I'm just off by like 1.5 thou. And if I had to sit and do a little thinking out loud, what's the solution? I don't know, but I do know that being off by 1.5 thou on a hole location is not what I'm going to want moving into the future. And let me take you into the office, and I'll show you what we're working on and why that's going to be important. Okay, guys, as you can see, this is an instrument that basically this entire structure hangs underneath the telescope. It's a big giant aluminum casting right here, and what we have is we have 2 instruments. This is Spiru and this is Espadons, and what we're trying to do is co-mount these 2 instruments with this structure right here. And as you can see, there's a ton of end work, so holes that come through the long side the hard way, and I just can't deal with those inaccuracies of sometimes 2 thou off. These 2 instruments have to be mounted in a plane that is very accurate, and the axes have to be spot on. So there's very little room for error. So this is the project that we're working on right here, or will be soon. It's in conceptual phase right now, but we'll be kicking this off soon. So I have to figure this out. So after all that work, what we came up with is that it's not my ability to edge find. That's within, like half thou. What's happening is when I drill a hole on the Bridgeport, that hole wanders. No matter how many processes I go through, that hole wanders just a little bit in a consistent manner. Which is why on the first test, the two dowel holes matched up between the CNC machine and the Bridgeport. So I can maintain that 8-inch space between the dowel holes, but that little bit of walk, that 1 thou, half thou little bit of walk, gonna have to work at getting that out of this machine right here. So let's just move on to the next little project. I started this yesterday, and I turned this out of a piece of square, flat plate, and I'll go ahead and show you that setup here. And did this side first, and then flipped it around, indicated, and turned the outer diameter, and then squared the face off to the proper depth. Now what we're going to have to do is set it up in the machine. This view right here is looking straight down. We're going to have to bore a pocket to a certain depth, 374 deep. We're going to have to relieve the edge. You can see right there that edge is relieved a little bit. And I don't know, that's like 20 thou is how much that little lip is right there. So 20 thou step down, bore the holes in a pocket, and then I've got a little bit of 3D work right here. And that should be fun. We'll probably do that with a 1/2-inch ball. So let's get this guy set up and get cutting. All right, we got the programming done on this. Yeah, we're just going to come in and rough this with a 1/2-inch. These pockets, we're going to rough them with a 1/2-inch. And then come in with a 3/8 ball. And I'm doing a high-speed raster pass on this side to finish up everything else. Same 1/2-inch, we're going to come in and clear this out with OptiRough, and then just a simple contour with a ramp into these holes. They're just clearance holes for bolts. And then if everything goes right, I'll program this flat to cut in here, and then come around the top with a little 45 and relieve all the edges. So let's see how this works. I tried to take into account the vice jaws, or the chuck jaws rather. This one should be right here, and then this one should be about right here, and hopefully there's enough material here, or there's enough room to clear this. We're going to go really slow and see if this works for us or not. We may have to make an adjustment. So here we go. It looks like with this lead in, lead out arrangement, we're going to have contact. So we're going to have to fix up the program. Okay, we figured out a way to reduce those lead-ins. Okay, all finished up. Yeah, the first thing everybody's going to see is a whole pile of chatter going on right here. And I talked to the guy I'm making this for, and he said these don't even have to be accurate. He said you could do it with a file and a grinder. So I mean, it's just a clearance for a wire to pass through, or a cable, or something like that, airline, something like that. I had a real long tool, and it chatted on me a little bit. I was already set up in the machine. It wasn't worth putting a shorter tool in, and it's just fine. For what this is, it's just fine. If I'd have put a shorter tool in, we would have got an amazing surface finish like all the rest of this, where it was digging in, heavy cut in the corner. That's why we got that little chatter. Anyways, all the edges are broke. You can see, right there, all the edges are broke. Yeah, it's a nice part. Very accurate to size. It's exactly what they asked for. And yeah, I think this is going on some sort of 3D printer for homes, actually. This thing will go and extrude cement into a predefined shape and create wall sections, I'm guessing. I don't know. Maybe we'll go out and see this at some point, but there's a prototype part. Anyways, we made a part today. That's cool. And you know, I'm pretty sure I figured out what's going on with my hole locations in the Bridgeport. Like I said, I got it down to it's actually the Bridgeport versus my method of edge finding. There is a more accurate method, of course. Will I do it? I might do a 3D taster for the Bridgeport as well, just to have consistency. We'll see. It won't be the digital one. It'll be the dial readout. It's about half price. We'll see. It's $500. I might be able to just figure out what that difference is. You know, touch the edge finder, and then compensate by whatever that half thou is. You know, whether it's in a little more, out a little more. We'll see. But I'm pretty confident I can move forward with the project that we did all that work for. Yeah, we'll see. We'll do a part and we'll measure it up, see how close I can get. Anyways, it's been a while since I posted. I've been doing a lot of design work. I got that little cool thing we just made, and I've got to start working on another project for a friend, doing a disc brake adapter for a big truck. So that'll be coming up. We got to design it up and kind of whittle out of aluminum a test piece, and then we'll make them out of steel for the finished pieces. Anyway, hope that was interesting, and stay tuned for more.